Hello and welcome to our presentation on line scaling. There's just a little slide showing what our agenda is for the presentation. First, I'll give you some general knowledge on the concept of scaling. Scaling involves a panelist sensing a product or stimulus and generating a response that reflects how the person perceived the intensity or strength of that stimulus. The response gathered from these kinds of tests can be used to illustrate differences in sensory attributes and the degrees of those differences. Scaling tests can use untrained panelists, which are typically used for dose-response curve problems, or they can also use trained panelists, which are typically used for descriptive analysis of products. And trained panelists are preferred in most applications. Line scaling is a type of scaling that was first done at the Michigan State Agricultural Experimental Station during World War II when they were testing the effect of storage temperature on the desirability of apples. The researchers discovered that the t-values were twice as large as they were when using the category scale, implying that the line scale is better at statistically differentiating products. The line scale is now widely used for quantitative descriptive analysis. Line scaling is a form of scaling where panelists mark their sensory responses on a line to indicate the intensity of an attribute. Each mark on the line is relative to one end of the scale, usually the lower end. Sometimes only the endpoints are labeled, and other times intermediate central reference points may be labeled to represent the value of a standard or baseline product, and then test products are scaled relative to this reference. Endpoint anchor lines may be indented to avoid panelists being reluctant to use the extremes of the scale. That's called endpoint bias, and the line should be about 6 inches long for maximum sensitivity, and the line scale may also be referred to as the graphic rating scale or the visual analog scale. Next are some rules for good practice when using the line scale. Number 1 is to provide sufficient alternatives. This allows for all possible distinctions of an attribute to be represented on the line. Not enough points on the line leads to panelists eliminating scoring options to add simplicity. Second rule is that the attribute in question must be understood by all the panelists. If a panelist doesn't understand what they are looking for, then they can't properly describe their sensory experience. And having trained, calibrated panelists ensures that this rule is met. Number 3 is that the anchor words must make sense. This ensures that the panelists aren't confused by any terminology and can give their most accurate responses. And lastly, the last rule is whether or not to calibrate your panelist. Calibration can cause bias and therefore can restrict responses. The decision to calibrate is left to the experimenter and reflects their desire to either work toward calibration or to address biasing and the restriction of responses. Here are the pros and cons of the line scale. The pros include that it's a simple procedure to do. The panelist choices are more continuous and less limited than the category scale. Minimal word and number biases exist when doing this test because the amount of words and numbers visible on the line are minimal, so people are less likely to see their favorite word or number and choose that due to their bias. Another pro is that humans are good at finding relative differences while we're bad at finding absolute differences. And lastly, the line scale is approximately as sensitive to product differences as the other scaling techniques. The cons include the endpoint bias, data limitations from potentially vague responses. Trained panelists are preferred, which just adds more complications to the whole procedure. And lastly, panelists may experience sensory fatigue from repeated trials, so they might just get bored essentially.
For the sample testing, we will be using trained panelists only because we are trying to determine the intensity of a specific sensory attribute, and in this situation, we are testing the color intensity of maple syrup. If untrained panelists were to be used, they wouldn't be able to distinguish the subtle differences in the color intensity of the different maple syrup products, because these maple syrup products would all look the same if we just look at it at first. So as a result, they would inaccurately measure intensity, and this would result in lots of variance and outliers in our data. Also, since there's no numerical rating system, evaluation system, the panelists are essentially eyeballing it. So this is why we're going to use trained panelists, because they're more experienced in noticing these small differences. Before a panelist is trained, they first must go through a screening process. In the screening process, the person must not be colorblind, have no maple syrup allergies, and have a good sensory acuity overall. So this means they can identify the basic senses, odors, and can rank solutions of varying intensities correctly. Also, the person must have an interest in becoming a panelist because when the time comes for a sensory test, the person who's interested, more often than not, will always put in an honest amount of effort so they can be accurate as much as they possibly can be, compared to someone who is not motivated or interested in becoming a panelist. Before the trained panelist participates in the sensory test, they first must be calibrated. And for calibration, we will use feedback calibration methodology, or FCM. In this method, panelists will complete a set of line scales and receive immediate feedback. The feedback will compare the results to an established score for a certain attribute for a particular product. This will provide the panelists with a reference point when they're trying to judge the color intensity of different maple syrups to allow them to be accurate as they possibly can be. For the line scale technique, we will be using 10 to 12 trained panelists. The number of panelists in this method is a lot smaller compared to the other sensory tests because we are trying to come to a consensus for how intense an attribute is. If too many panelists are used, it will increase the variance in our data and it makes it difficult to come to a consensus. But if too little panelists are used, then we don't have enough data to be confident that our consensus is actually.
When preparing the samples, equal syrup amounts are necessary for color accuracy. More or less of a syrup than other samples can alter the perceived color. It is important to randomize sample order so that the samples are not presented in a color gradient, which can alter the perception and affect panelists' decisions. Random numbers are assigned to the syrups to remove brand bias or preconceived ideas about the syrup based on labels. For example, premium syrups are usually associated with a darker color and could affect panelist decision making. As this test focuses on the colors of the syrups, the panelists will not be tasting and will not need utensils or palate cleansers. Just the samples, a pencil or pen, and questionnaire on the tray is all that will be needed. The questionnaire itself is very simple. It will contain the product code, a line scale, and an example can be seen on the slide of what a line scale could look like, and instructions as to how the panelists will be rating each syrup. In this case, it is the likeness of the color from darkest to lightest. When presenting the samples, the room the test is being conducted in should be free of any distracting items. That is, no posters, no plants, nothing of color that could draw the person's attention away from the samples in front of them. The walls themselves should be neutral background colors, such as white, gray, or cream colors. This provides a contrast to the syrups and cannot be used as an external color comparison tool. Direct light overhead is important so that no shadows are cast in the syrups, which could darken the perceived color. The light strength range should be 750 to 1200 lux, and it should be in the 500 to 600 range. This will give pure white light. Colored light of any type will affect the color perception and alter the panelist's responses. The distance light travels can cause glare, and using diffused lighting will prevent this. The panelists, when the test is ready, will enter the room and sit down. They'll be presented all samples at the same time. They can then read the questionnaire, assess the samples, record their answers on the line scale, and then leave as they have finished the test.
So after sending out the surveys, we need to use a ruler to measure each mark to 1 decimal place. A reminder that we can't use table FJ from class because that's only for rank sum differences. With the measured data, we need to put it into an ANOVA table. One way ANOVA tests are typically done, since we are only using one independent variable to affect our results. However, you can use other independents to see if they affect your results too. So, an analysis of variance test would be done by putting the data into an Excel sheet. Our null hypothesis is that the means of each sample are relatively the same, whereas the alternative is that at least one of the means are significantly different. If the ANOVA results show that the p-value is lower than 0.05, or if the f-value is higher than the f-critical value, we can reject the null hypothesis and instead accept the alternative by saying that one of the means are significantly different. However, the ANOVA test doesn't tell us which mean value is different, so we need to do a Tukey test. First, we order the means from the highest sum to the least, and then subtract each mean from each other. Next, the formula to do a Tukey test involves this formula for the Q critical value. You'll need to use this chart for the Q value and then find the standard deviations and total number of samples. If the mean is larger than the Q critical value, then the two groups are significantly different from each other. Therefore, give them different letters. Or you can just use a free software to do the Tukey test for you. So we tried out this experiment for ourselves. Maple syrup is categorized by taste, as well as the amount of light seen through the liquid by using a spectrophotometer. Processing grade syrup is any syrup that has impurities or off flavors. Therefore, they're typically darker than the cleaner syrups. The objective of this survey was to see if people could notice a difference between maple syrup colors. We sent out the surveys online. I was using 4 types of syrup, and to ensure each product got an equal amount of times being used first, we counterbalanced, using permutations with 4 syrups being chosen with no repeats. That gives us 24 unique blocks. I made sure to use blocks where each sample got to be in each position once, so 4 specific blocks. When making the survey, we considered a scale that already had 1 decimal place markings to make it easier to measure, but the online survey only allowed for a slider scale. It should be noted that these formats would ruin the integrity of the align scale, as it's meant to give the illusion of choice. We quickly calibrated the panelists by showing them pictures, and where the photos laid on the line scale. Panelists had to click I understand to confirm that they understood the colors. We included indented anchors of very light and very dark, so that they also have the option to go past these points if necessary. The questions in the survey only ask them, where does this sample fall on the line scale? With the 4 blocks in the survey, it meant that the panelists would repeat the same samples 4 times. These repeated samples assures precision. As shown by an example, this person got similar results for very dark. 4 sample colors multiplied by 4 repeats multiplied by 12 panelists gives us 192 data points, which is quick, cheap data. Now that surveys are done, I placed them into an Excel sheet. I saved it as a CSV file and then placed it into R. Here's an example question of the survey with the 3-digit codes changing for each product, the sample picture, the line scale, and the decimal place that they had to type in because I couldn't measure it myself. So the program R did the ANOVA test. As we can see, the p-value is below 0.05, so one of the means are significantly different. A follow-up Tukey test was done, and it shows each sample was significantly different enough to deserve its own letter. We also see that the means corresponding of each syrup was pretty close to where they matched on our defined line scale. The standard deviation shows that each sample almost went a full 0.9 decimal place over from its defined place on the line. So in hindsight, a line scale is much easier digitally. The reason being is because I wouldn't have to measure each line to 1 decimal place. It was pretty similar to a slider scale, which was a free option on free survey websites. CompuSense also shows that it's as easy as a single touch on a tablet. Here are some other facts about the line scale. Humans do naturally compare things. In the example video provided in class, we saw a line scale where all the samples were placed on the same line for that attribute. This may cause bias, but it clearly shows an obvious difference in products, which is the goal. CompuSense says that immediate feedback releases dopamine, which makes calibrating much quicker. This can also be said for learning in person or real-time lesson. To wrap up, I'll be showing 2 slides comparing tests while I read these facts. Here are 2 color blindness tests, Ishihara plates, where you need to see the number in the circle, and Farnsworth tests, where you order the colors correctly based on hues. Here's a quick comparison of discrimination, effective, and descriptive tests. Brix measurements are for sugars in the solution, while Beaumet is for salt. Syrup gets darker in the later seasons because there is less sugar and more microbes. Less sugar means more boiling takes place to condense the product. The microbes break up sucrose into glucose and fructose. Boiling sterilizes, as well as causes Maillard browning of amino acids and unbound sugars to give the dark color. Lastly, a quick comparison of our 3 descriptive scales. I wondered what influenced the anchor words of opposites, for example, light versus dark, or negation, using very and not very. And I came across a paper concluding that people who are more informed about the world were more optimistic. Informed as in being aware of problems, understanding relations, and culture. This concludes our presentation.